Hello everyone. Today we're going to continue with inequalities. We're going to review how to solve one-step inequalities as well as two-step inequalities. And last but not least, we're going to do a bunch of two-step inequality word problems together. So let's start back with one-step inequalities. So when you are solving an inequality, the good news is you're just going to use the same exact procedure that we've been using to solve equations. But we'll notice with inequalities, there's no equal sign. We're dealing with our less than or greater than sign. We're also dealing with our less than or equal to or greater than or equal to sign. But basically, when the most important thing that you need to know about solving an inequality, it says it right here. When multiplying or dividing by a negative number, you're going to reverse or flip the direction of your inequality sign. So let's take a look at the first example. So we've got negative 3x is less than 6. So obviously the whole goal is to get our variable by itself still. So in order to do that, to get rid of my coefficient, I would need to divide both sides by negative 3. Now, because I'm dividing through by a negative, that means I'm going to flip my inequality symbol, and 6 divided by negative 3 is negative 2. Now, we've already talked about graphs, so if I were to graph this, let's put negative 2 in the center, which means negative 1 would go to the right of it, and negative 3 would go to the left. It's going to be an open circle, and because x is greater, we would draw our arrow to the right. So now, what that means is if I take any number to the right of negative 2 and plug this in, it will work. So for example, let's say I plug in negative 1. So negative 3 times negative 1 is a positive 3. And is 3 less than 6? Yes. So it works. Let's say I were to take 0. 0 would be to the right of negative 2 on the number line. Negative 3 times 0 is 0. And is 0 less than 6? Yes. Now, let's say for some reason I choose a number that's not in my graph. Let's say I plugged a negative 3 in. Well, negative 3 times negative 3 is a positive 9. Is positive 9 less than 6? No. So now you can see only the numbers included in your graph are considered solutions. They would work in your inequality, whereas numbers that are not in your graph, like negative 3 in this example, will not work in your inequality. It would not be true, a true statement once you solve it. All right, so let's try some more of these. So we've got x plus 3 is less than 5. Again, we just have a one-step inequality, so I'm going to do the inverse operation. So I'm going to subtract 3 on both sides. Notice I'm not multiplying or dividing by a negative, so nothing flips. I'm just subtracting by 3. So that's going to leave me with x is less than, and 5 minus 3 is 2. So if I were to graph this, I would draw an open circle, and since x is less than that, our arrow would go to the left. Here I've got 5d is greater than 15, so I'm going to divide both sides by 5. That's going to cancel there, and leaving me with d is greater than 3. So let me just move that. So I'm going to do an open circle again. Since d is greater than 3, we're going to go to the right. So you're basically just solving them like you would an equation. However, you're just dealing with a different symbol, and then we've got that one exception for when we multiply or divide by a negative. I'm just going to rewrite this one off to the side a little bit so it's a little bit easier for me to solve. So I've got a negative 36 plus x is less than 8. I want to get x by itself, so I need to get rid of this negative 36. So to get rid of it, I'm going to add 36. What we do on one side, we do to the other, and that's going to leave me with x is less than, well, 8 plus 36 is 44. So your solution here would be x is less than 44. Let's try another. I've got negative x is less than negative 29. Again, I'm just going to move this over here. Now, as you can recall, we can never have a negative variable. Remember, when x is by itself, it's understood that there is a 1 in front of it. So let's put a negative 1 there. So if I were to try to get rid of my negative 1, since this is multiplication, we would do the opposite, which is division. Notice that I'm dividing by a negative, which means my symbol is going to flip. -1 divided by -1 gives me a +1, or a positive x, and -29 divided by -1 is a positive 29. So your solution here would be x is greater than 29. If I were to graph this, it would be an open circle going to the right. Okay, here's a different type of a problem. Notice that we have a fractional coefficient. So in order to get rid of our fraction, just like we did with equations, we have to multiply by the reciprocal. So obviously our reciprocal for 4/5 would be 5/4. And what we do to one side, we do to the other. Everything cancels here, leaving me with t by itself. I can cross simplify here. And that's going to leave me with 2 times 5, which is 10. And then just 1 in the denominator, so 10/1, which is equivalent to 10. So t is going to be greater than 10, which means we would have an open circle going to the right. Okay, let's do a few two-step inequalities. So again, same process. However, we just have that extra rule where if you multiply or divide by a negative, you need to flip your inequality symbol. So the first thing we would do here would be to eliminate our constant, which is -1. So I'm going to add 1. So that's going to leave me with 7h is less than or equal to 6 plus 1 is 7. And then to get rid of my coefficient, we would divide both sides by 7, leaving us with h is less than or equal to 1. As you can see, there's a graph below. So I'm going to build my graph around my solution, which means I'm going to put my solution, which is 1, in the center, which means 2, 3, 4. And then to the left, you'd have 0, -1, -2. So I've got h is less than or equal to 1, which means we're going to have a closed circle at 1. And since it's less than or equal to, our graph will go to the left. So if I were to take 0, since that's included in my graph, and plug it in where h is, 7 times 0 is 0. 0 minus 1 is -1. Is -1 less than or equal to 6? Yes, it's less than, so it's true. If I were to plug 2 in, notice 2 is not in my graph. It's not going to work. 7 times 2 is 14. 14 minus 1 is 13, and 13 clearly is not less than or equal to 6. All right, let's try another one. It says, which graph represents the solution set of this inequality? Well, the best thing to do here is to just solve your inequality. So let me rewrite it. We've got 9 minus 4d is greater than or equal to -3. So in order to get my variable by itself, I'm going to subtract 9 on both sides first. We're eliminating our constant. That leaves me with -4d is greater than or equal to -3 minus 9. Remember, we have to keep change, becomes -12. And then now I'm going to divide through by -4. Be careful here. Notice I am dividing by a negative, which means what happens to our inequality symbol? It flips. And a -12 divided by a -4 is going to be a +3. So we're looking for a closed circle at 3. So right away I can eliminate C and D. And it's less than or equal to, which means your arrow should be going to the left, which makes A the correct answer choice here. Okay, let's keep going. Try another one. All right, so we've got 4x minus 1 is less than 11. So our first step here would be to add 1 on both sides. That's going to leave me with 4x is less than 12. And then to solve, we would just divide both sides by 4, leaving me with x is less than 3. So you can see in this type of problem, they're giving you a drop down. So you're going to have to choose which symbol it should be, which would be less than. And then you would just type your solution in, which is 3. Okay, here we've got variables on both sides. So when you are given an inequality with variables on both sides, your whole goal is to get all your variables to one side and all your constants to the other. Now, I try to keep my variable positive just because it makes it less complicated because you don't have to do any flipping of symbols that way. So if I was going to move my variable, I would either subtract 2x here on both sides or I would subtract x. I'm going to go with subtracting x because I know that that's going to keep my variable positive. If I had subtracted 2x, I would have been left with a negative variable. And like I said, I try to keep my variables positive. So 2x minus x, or 2x minus 1x, is going to be 1x, or just x. So now we're left with just a one-step inequality. X plus 3 is greater than 5. So I'm going to subtract 3 on both sides. And that leaves me with x is greater than 2. Again, we're going to build our graph around our solution. So I'm going to put 2 in the center and build the graph around that. And it should be an open circle. And because x is greater than 2, we're going to go to the right. Okay, here's another one where we've got variables on both sides. So I could either be subtracting 5m or I could subtract 2m. I know that by subtracting 2m, I'll keep my variable positive. So I'm going to go with that. 5m minus 2m is 3m. That leaves me with 3m minus 8 is greater than or equal to 10. Now we just have a two-step inequality. I'm going to add 8 on both sides. That leaves me with 3m is greater than or equal to 18. And then I'm going to divide through by 3, and that's going to leave me with m is greater than or equal to 6. So we're going to build our graph around our solution. It should be a closed circle at 6. And since m is greater than or equal to, we're going to go to the right. Okay, let's do a few more. Notice I have a negative variable here. So the first thing is eliminate your constant. We're going to subtract 6 on both sides. Remember, negative 9 minus 6, keep change, is going to give me negative 15. And then I've got a negative in front of my variable, which we can't have. Remember, it's like having a negative 1. So we're just going to divide through by negative 1. I am dividing by a negative, which means that my symbol is going to flip. And then a negative divided by a negative is a positive. So let's put 15 in the center. And we're going to have a closed circle at 15. And since q is greater than or equal to, we're going to go to the right. These do get easier the more that you do. Okay, again, a negative variable here. First, let's eliminate our constant. We're going to add 13 on both sides. That leaves me with negative r is greater than or equal to 23. And then to get rid of my negative, I'm going to divide through by negative 1, which means my symbol is going to flip. And 23 divided by negative 1 is negative 23. Let's put that in the center. Remember, we're on the negative side of the number line. So just be careful when you're filling it in. So I missed one over here. And we're going to have a closed circle at negative 23. And since r is less than or equal to, we're going to go to the left. Okay, I've got one more of these. Notice now I have parentheses, which means we need to distribute. So let's draw our arrows. Negative 3 times 4h is negative 12h. Negative 3 times 5 is negative 15. Next step, we're going to add 15 on both sides. That leaves me with negative 12h is less than or equal to negative 15. And then I'm going to divide through by negative 12. I am dividing by a negative, which means that my symbol is going to flip. I've got a negative divided by a negative, which gives me a positive. And then we can simplify. If you're going to get a fraction as your answer, you're always going to want to simplify it. So 15 divided by 3 is 5, and 12 divided by 3 is 4. So your solution here would be h is greater than or equal to 5/4. Okay, we're going to finish off today with some word problems. We're going to start off very basic. 4 times a number is greater than 24. Well, 4 times a number means 4 times n or 4 times x, whichever variable you're using, and then is greater than would be your greater than symbol, 24. 3 times a number minus 4 is less than 12. Well, 3 times a number would be 3x, minus 4 would be minus 4, and then is less than 12. This is where it can start to get a little tricky. Notice the key word here is minimum. The minimum speed on the highway in Massachusetts is 40 miles per hour. Well, think about it. Minimum means that's the lowest you should be going. The least speed that you should be going is 40 miles per hour. So that means that X should be greater than or equal to 40 miles per hour. They actually used S here because they were referring to speed. So S would be greater than or equal to 40. You've got to be careful with your wording. Here's some key words that you might see and which symbol they represent. So here with less than, we've got less than or fewer than. And then for greater than, you have more than or exceeds. Exceeds is a good one. You might see less than or equal to, no more than, at most, and maximum. I'm going to put a little box around these. Those are very common words that we see in inequality word problems. Think about it. If you hear the word, I want to spend at most $100 on a new pair of sneakers, that means you don't want to spend more than $100. So you want to be less than or equal to $100. And same thing over here. At least and minimum. We just saw a minimum in the last problem. That's going to indicate your greater than or equal to symbol. Okay. I want to spend at least 5 hours at the beach today. Means that I definitely want to be there for 5 hours and hopefully longer than that. So now that we've gone over some keywords, let's do a few of these problems. It says a number is decreased by -4. A number decreased by -4. Decreased means subtraction. By -4 is at least, which what did we say at least was? Let's go back. At least would be greater than or equal to 9. Well, I've got a double negative here, so if I were to keep change, that becomes n plus 4 is greater than or equal to 9. And then to solve, we would subtract 4 on both sides, leaving us with n is greater than or equal to 5. Let's try another one. It says your weekly base salary is $150. You can earn $20 for each cell phone you sell. Write and solve an inequality that represents the number of cell phones, C, that you must sell to make at least $630 a week, which means you want to make $630 or more, which means greater than or equal to. So just like we did with the equations word problems, we're going to kind of work backwards here. Now, my variable is C for cell phones. So C represents the number of cell phones. So looking back at my problem, what number has to do with the cell phones? Well, it says right here, you can earn $20 for each cell phone you sell. So that's $20 per phone. So 20 times C, the number of phones. And then you also earn a base salary of $150. So plus 150 is greater than or equal to 630. To go ahead and solve this, we're just going to follow our steps. I would subtract 150 on both sides. That's going to leave me with 480. So we've got 20C is greater than or equal to 480. And then we just need to divide through by 20. And that's going to leave me with C is greater than or equal to 24. So what does that mean in the context of the problem? It means you want to sell 24 or more cell phones in order to make at least $630 per week. Okay, let's try the next one. The TOIS Math Club is trying to raise $1,000 raffling off a Nintendo Switch. They have already made $100. If they sell raffle tickets for $15 each, how many more tickets must they sell to make at least $1,000? There's that at least again. So that means we want to make greater than or equal to $1,000. We're trying to find T, number of tickets. Well, what number in the problem has to do with the tickets? Right here, they tell you the raffle tickets are $15 each. So 15 times the number of tickets plus the $100 they already made is greater than or equal to 1,000. So now to solve, we're going to subtract 100 on both sides. That leaves us with 15t is greater than or equal to 900. And then our last step would be to divide 900 by 15. 15 goes into 900 60 times. You can use your calculator, obviously, for these. So basically what that means is that you need to sell more than 60 tickets in order for you to make, oops, I changed my symbol here, greater than or equal to 60. So T is greater than or equal to 60. So you need to sell 60 or more tickets in order for you to make enough money. Let's try another one. Tatiana wants to give friendship bracelets to her 32 classmates. She already has 5 bracelets and she can buy more bracelets in packages of 4. Let P represent the number of packages. Write an inequality to determine the number of packages she needs to buy. Well, she wants to make them for her 32 classmates. So that means that she needs greater than or equal to 32. So she already has 5. Plus, she needs to buy them in packages of 4. So plus 4 times the number of packages. So now let's go ahead and solve it. I'm going to subtract 5 on both sides. This is where some of them can get a little tricky. So we've got 4p is greater than or equal to 32 minus 5 is 27. And then if I divide through, notice that it's not going to divide evenly. I'm going to end up with, let's just convert it to a mixed number. So 4 goes into 27 6 times, and you have 3 left over. So she needs to get 6 3/4 packages or more. Now, can you buy 3/4 of a package? No. And they want to know what's the minimum number, whole number of packages she needs to buy. Well, if she buys 6 packages, she won't have enough, which means how many packages does she need to buy? 7 packages in order to have enough. So some of these problems you may need to round your answer. You just need to read the problem carefully, look at the context of it, and see what they're asking you to do. All right, let's do one last one together. It says a concert is being held in a gymnasium that can hold no more than 550 people, which means we can have exactly 550 or less than 550. A permanent bleacher will hold 30 people. The event organizers are setting up 20 rows of chairs. At most, how many chairs C can be in each row? So 20 times the number of chairs. And there's our inequality. So to solve it, we're going to subtract 30 on both sides. That leaves me with 20C is less than or equal to 520. We're going to divide through by 20. And that's going to leave us with, let's see, 23 times, nope, that's not right. Hang on. So that goes in 26 times. Oops. So that means that you can have 26 or less chairs in each row in order for you to keep the capacity of the gym at 550 people or less. So that does it for today. The correlating note-taking packet pages are pages 30 through 35. And again, if you want to see some additional examples, you can watch the videos in Khan Academy. Have a great day, everyone.